Imagine this. You're going about your day, the sky looks normal, the earth feels solid beneath your feet, nothing feels wrong, and yet, somewhere in the universe, something impossible has just happened. A black hole has appeared. Not the kind you see in movies, not a giant one swallowing stars, something much smaller, something far more dangerous, a micro black hole, and it's on a collision course with Earth. You wouldn't hear it coming. You wouldn't see it coming. There would be no warning sirens, no fireball in the sky, just silence. So, the question is, what really happens if a micro black hole hits Earth? Does the planet instantly collapse? Does it pass straight through us? Or does something far stranger occur? Tonight, we're going to slow this moment down, second by second, atom by atom. And by the end of this video, you'll understand why this question terrifies physicists more than almost anything else in space. Before we go any further, we need to clear something up. Black holes are not cosmic vacuum cleaners. They don't roam the universe, sucking everything into them. A black hole is simply a place where gravity becomes so strong that space itself bends inward. At the center of every black hole is something called a singularity, a point so dense that the laws of physics break down. Around it is the event horizon. Cross that invisible boundary, and nothing, not even light, can escape. Now here's the part most people don't realize. If you replace the sun with a black hole of the same mass, Earth would keep orbiting normally. No sudden destruction, no apocalypse. So why does the idea of a micro black hole scare scientists so much? Because size is not the danger. Density is. A micro black hole is exactly what it sounds like. Extremely small. Smaller than an atom, but don't let that fool you. A micro black hole could have the mass of a mountain, or the mass of Earth, packed into a space smaller than a proton. That's like compressing Mount Everest into a grain of sand. These black holes don't form from dying stars. They might be created during the earliest moments after the Big Bang, when the universe was unimaginably dense. Some theories even suggest they could be created in high-energy particle collisions, though none have ever been observed. And if one exists, it would be invisible, silent, and unstoppable. Now imagine this right now. A micro black hole enters Earth's atmosphere. Nothing explodes, no shock wave, no flash of light, because it's too small to interact with air the way a meteor does. It passes through clouds, through oxygen, through nitrogen, straight toward the surface, at nearly the speed of light. In less than a second, it reaches the ground, and then it goes straight through the planet, like Earth isn't even there. Here's where things get strange. You might think the black hole would start eating Earth from the inside, but it doesn't. At least, not immediately. Why? Because gravity depends on distance, and a micro black hole is so tiny that its gravitational pull only becomes intense extremely close to it. Most atoms inside Earth never get close enough. So, as the black hole passes through the planet, it consumes almost nothing. Maybe a few atoms, maybe a few subatomic particles. Earth barely notices. No earthquakes, no cracks in the crust, no collapse. If this were the end of the story, we wouldn't even be talking about it. But the real danger isn't the first pass. It's what happens next. Most micro black holes would fly straight through Earth and disappear into space forever. But there's a terrifying possibility. What if it doesn't escape? What if it loses just enough energy to become gravitationally bound to Earth? Now, imagine a black hole orbiting inside the planet, passing through the core, then the mantle, then the crust, over and over again, each time consuming tiny amounts of matter. At first, nothing changes, but slowly, very slowly, the mass of the black hole increases and gravity begins to win. This wouldn't be dramatic. It wouldn't happen in a day or a year. It could take millions or even billions of years. But eventually, the black hole would grow. Earth's core would become unstable. Heat distribution would change. The magnetic field could weaken. Volcanoes would increase. Earthquakes would become more frequent. The planet would start to behave wrong. And long before the black hole ever became large enough to destroy Earth, life would already be gone. Here's the twist. According to physicist Stephen Hawking, black holes are not eternal. They slowly lose mass through something called Hawking radiation. The smaller the black hole, the faster it evaporates. A micro black hole might not survive long at all. Some would vanish in fractions of a second, releasing a burst of energy and disappearing forever. If that happens, Earth is safe. No damage, no consequences. Just another strange event the universe never tells us about. The good news? There is no evidence that dangerous micro black holes exist near Earth. Cosmic rays hit our planet constantly, with energies far greater than anything humans can produce. And Earth is still here, which tells us something important. If micro black holes form, they are either harmless or they don't last long enough to matter. But here's why scientists keep asking this question. Black holes test the limits of reality. They sit at the intersection of gravity, time, space, and quantum physics. Understanding them means understanding how the universe began, how it might end, and whether reality itself has limits. A micro black hole hitting Earth isn't just a disaster scenario. It's a thought experiment, one that forces us to confront how fragile our understanding truly is.